Hello and welcome to SLRTP at ECCV 2022. My name is Hannah Bull and I'm a PhD student and one of the organizers of this workshop. As part of the workshop, we have organized 3 data challenges on 2 different sign language datasets, which I would like to tell you about today. The goal of the SLRTP 2022 challenges is to encourage usage of diverse, large-scale and large vocabulary sign language corpora for sign language understanding. Firstly, I will talk about the 2 British Sign Language datasets used for the SLRTP 2022 challenges. The first dataset is BobSL, the largest sign language dataset currently available for academic sign language research. The second dataset is BSL Corpus, which has a very diverse range of 249 deaf signers. Secondly, I will describe the 3 SLRTP 22 challenges on sign recognition, subtitle alignment, and sign spotting, and go through some baseline methods which you could work with and build upon. The BobSL dataset comes from a collaboration between a number of researchers, led by the BBC and Oxford, and has 1,400 hours of British Sign Language video with English subtitles. It is available for academic research purposes. You can take a look at the link on this slide for information about BobSL and how to access the data. Interpreted TV data is a great way of obtaining large sign language corpora with written text annotations from the subtitles. BobSL comes from BBC footage with British Sign Language interpretation from both deaf and hearing interpreters, as well as English subtitles. The interpreter is cropped out of all of the BBC videos. The interpreter's face is not blurred, however, any other background faces are blurred to protect privacy. The subtitles have been merged into sentences in order to facilitate working with text sign language video sentence pairs. BobSL is enriched by over 2 million automatic sign annotations. These sign annotations come from querying words in the neighboring subtitles and then searching for these signs in the sign language video. To find signs, it is possible to look for mouthing cues if the interpreter simultaneously mouths the word that they are signing. We can also look up signs in online BSL sign language dictionaries to see whether or not they are present in a segment of continuous signing. In a CVPR 2021 paper, Varol et al. Also used peaks in attention maps to spot signs. A subset of the automatic sign annotations are verified by native deaf signers for evaluation purposes. Moreover, some of the subtitles have also been manually aligned to the sign language video in order to create accurate video text sentence pairs. This annotation is done using the VIA tool, which is a freely available software well suited for video annotation. BobSL has around 1,400 hours of signer interpreted video with English subtitles. This comes from nearly 2,000 episodes of BBC programs, interpreted by 37 signers. There are over 1 million subtitles with a vocabulary of 77,000 words. Additionally, there are automatic and manual annotations as parts of the train, validation, and test splits of BobSL. There are over 2 million automatic sign annotations, which can be used, for example, for training sign classification models on continuous signing. There are also more than 30,000 manual alignments between segments of sign language video and subtitles. These alignments can be used, for example, for learning how to localize text sentences in sign language video. There are around 25,000 manually annotated test signs, which can be used to evaluate sign classification models. The train, validation, and test splits of BobSL are based on signers, such that there is no signer overlap between the splits to allow for signer-independent evaluation. The train set has around 1,200 hours of BSL video with 1 million weak sentence annotations and 27 different signers. There is a private test set which can be used for data challenges where the annotations are not publicly available. We use part of this private test set for the SLRTP challenges on BobSL. The BBC programs in BobSL cover a wide range of topics. There are plenty of science shows, children's shows, cooking shows, documentaries, comedy, and a very large vocabulary, both in the signing and in the subtitles. This makes BobSL a difficult dataset to work with, but also makes BobSL more representative of the unconstrained vocabulary used in all kinds of different interactions. Due to the signer-independent splits and the allocation of particular interpreters to particular programs, there are certain topics which are overrepresented in the training set or in the test sets. For example, there are many life stories and money programs in the training and validation sets, but almost none in the test sets. On the other hand, there are relatively few medical shows in the training sets, but many in the test sets. Another difficulty of BobSL is that the subtitles are aligned to the audio track and not to the signing. Due to the interpretation process during production, there is on average a 2.7-second lag between the audio track and the signing. Manually aligning subtitles to the signing requires shifting them and rescaling them to match the signing. Most work in machine translation between written languages uses sentence-level pairs for training. The fact that the subtitles are not aligned to the signing means that BobSL has a relatively large uncertainty when trying to construct similar sentence-level pairs between sign language video and subtitle text for sign language translation models. Moreover, the subtitles only provide weak cues to the signs used in the corresponding video segment. Not all words in the subtitle are signed, and not all signs correspond to words in the subtitle. Not all signs are lexical signs with an English word translation. There are also many pointing signs and depicting signs. Most importantly, BobSL is interpreted sign language data and is not representative of natural, spontaneous daily sign language usage by deaf signers. The BBC interpreters are highly skilled, but they are not all deaf native signers. There are a wide range of topics covered in BobSL, but these topics can be quite different to interactions in daily life. There is also no doubt some source language interference when translating from written or spoken English to BSL. The time constraints in interpretation may also artificially change the style and rhythm of signing. These representativity and generalizability issues must be taken into account when considering applications of models trained using BobSL. The BSL corpus gives us a way to train and evaluate methods on non-interpreted data. The BSL corpus contains 125 hours of BSL interviews, conversations, and narratives from 249 deaf signers. Let's watch a short example. BSL corpus is available for academic research purposes, and a subset of these videos are even available to anyone for any purpose, such as teaching or research. The link on this slide shows you how to access this corpus. The BSL corpus comes with some manual annotations, notably 72,000 sign annotations from a 5,000 gloss vocabulary. Moreover, there are 2,000 manually verified mouthing annotations on the test sets for evaluation purposes. We can consider a subset of BSL corpus with dense gloss annotations. This means we look at the available sign gloss annotations and take segments where there are at least 3 consecutive gloss annotations. On average, these densely annotated video segments have 7 glosses and an average duration of 3.2 seconds. These segments are then split by signer, allowing for signer-independent evaluation on the validation and test sets. The training set contains over 5,000 video segments from 157 signers, with a gloss vocabulary of 969. This densely annotated segment of BSL corpus is particularly interesting for sign spotting or for dense annotation tasks. Given a segment, we know exactly which glosses are present and which glosses are absent. Now I would like to talk about the 3 SLRTP 2022 challenges that we've released for BobSL and BSL corpus. The goal of these challenges is to encourage researchers to work on large-scale sign language data, but to also use non-interpreted data from deaf signers when training models for sign language technologies. All of the information about the challenges is on the SLRTP 2022 website. We are using CodaLab as a platform to submit predictions on the development and test sets, and you can find a link to the CodaLab platform on the SLRTP website. The first challenge is about sign recognition on BobSL. The task is, given a point in time within a co-articulated sign language video, classify the sign into one of the categories in a 2,281 word vocabulary. In the displayed segment of video, we are looking to classify 2 signs at 2 different video locations. The ground truth annotations here are elephants and curious. We provide model weights for a baseline i3D model for sign classification. This i3D model is trained using 500,000 automatic mouthing annotations and 1.5 million automatic dictionary annotations, and predicts signs within the vocabulary of 2,281 classes. The main evaluation metric is the top 1 sign classification accuracy with class balancing. That is the average top 1 accuracy per class. We also include the top 1 class accuracy per instance, that is without class balancing, in addition to the top 5 accuracy with and without class balancing as supplementary evaluation metrics. For our baseline method on the development sets, the top 1 class accuracy with class balancing is 50.47. For our baseline method on the test set, the top 1 class accuracy with class balancing is 48.61. The second SLRTP challenge is about subtitle alignments. As mentioned before, in the BobSL dataset, the subtitles are not aligned to the signing, but to the spoken audio. The task here is to align subtitle text to sign language in order to create pairs of written sentences in their sign language interpretation. In this figure, the first line shows the audio aligned subtitles. In the second line, the subtitles have been manually shifted and stretched in order to align to the sign language video. Our baseline method is a transformer encoder decoder model. Basically, we provide the model with 3 inputs: the subtitle text, which we want to localize, a 20-second window of sign language video in which we want to localize the subtitle text, as well as a good guess of the localization from the audio aligned subtitle. The model then matches the subtitle text to the corresponding part of the signing within the 20-second window. We provide code for this model on GitHub, as well as model checkpoints, which you can use to train and evaluate different versions of this baseline. An even simpler baseline is to just shift the audio aligned subtitles by 2.7 seconds, as this is the average lag between audio aligned and signing aligned subtitles on the manually annotated training sets. The transformer-based model improves upon this baseline. Our main evaluation metric here is the F1 score using an overlap threshold of 0.5 IOU between predicted and ground truth subtitle locations. We also include frame accuracy and F1 scores at 0.25 and 0.1 IOU thresholds as supplementary evaluation metrics. The results for the transformer model appear on the CodaLab competition leaderboard. In the third SLRTP challenge track, we use non-interpreted data from the BSL corpus. Here, the task is sign spotting. Given a query sign gloss and a short video of continuous sign language, firstly determine whether or not the video contains the sign gloss, and if so, localize the sign gloss. For example, Given 3 query glosses, cat, select, and jump, we decide whether or not these query glosses are present in the segment of sign language video, and if so, we localize the sign. Our baseline model is very similar to the baseline used in track 1. We take the same i3D model trained on BobSL automatic mouthing and dictionary annotations and apply it to the BSL corpus data. The i3D model predicts signs at each frame, and in particular, we look at the top 5 predictions at each frame. If the query gloss is present amongst these top 5 predictions, then we say that we've localized the sign gloss at the corresponding frame. If the query gloss is not present amongst the top 5 predictions, then we conclude that the query gloss is absent from the sign video. For example, if select is one of the top 5 i3D predictions at frame 7, then we say that the sign for select is at frame 7. We provide code for this baseline from GitHub. Moreover, this baseline model runs directly from i3D model outputs. We provide the i3D model features and logits for the BSL corpus data, and so actually the original RGB videos are not necessary to run this baseline. Our evaluation metric is essentially the sum of correct predictions, correct absences, incorrect predictions, and incorrect absences of query signs. The baseline score on the development set is 20, and the baseline score on the test set is 28. The test set is slightly different from the development sets. In the test sets, we also include some manually verified gloss annotations, which are not part of the densely annotated subset of the BSL corpus. These manually verified annotations are only used as positive queries, where the ground truth sign is present in the video segments. If you know any other researchers who are interested in sign language, then please let them know about our 3 SLRTP 2022 challenges. The CodaLab platform will remain available to make it easier for everyone to compare results on sign recognition, subtitle alignment, and sign spotting. Other datasets may also be used for training, so long as the data or the model weights are available to other researchers. We provide baseline code and baseline models for all of the challenges to help you get started. Before opening the floor to questions, I'd like to share a question that we have for you. We'd like to know how we can make it easier for people to participate in this challenge. We know that BobSL is a difficult dataset due to its size. It takes time and resources to train models on BobSL. Also, it can be a little complicated obtaining access to BobSL and BSL corpus, as you can't just download this data, someone needs to grant permission, which can take a few days. Perhaps we can provide better code or better resources to help get started, and we'd appreciate your thoughts on this. Please also feel free to ask us any questions about the SLRTP 2022 challenges that you may have.